In this episode, we're going to make cloud networking feel understandable and security relevant without turning it into a maze of provider-specific details. Cloud networking is one of the most common places where organizations accidentally create exposure, not because they want to be reckless, but because cloud networks are flexible and the consequences of small changes can be surprisingly large. Beginners often carry a traditional network mental model into the cloud, expecting a single perimeter and a few obvious choke points. But cloud networks are usually built from many small policy decisions that add up over time. Those decisions include what can talk to what can talk to the internet, and what paths exist between different parts of an environment. Security groups and network access control lists, often abbreviated as NACLs, are two common types of controls used to shape network access, and understanding them at a high level helps you reason about exposure and lateral movement risk. Routing is equally important because routing decides where traffic can go, and a routing mistake can create an exposure path even when your access rules look strict. By the end of this, you should be able to explain what these controls are meant to do, why routing matters for security, and what exposure mistakes tend to look like in real cloud environments. A useful starting point is remembering that networking security is fundamentally about controlling paths, because attackers move along paths just like legitimate users and services do. In a cloud environment, you can think of paths as the allowed connections between resources, such as between a user and an application, between an application and a database, or between a management system and an administrative interface. Each path is shaped by multiple layers of control: identity permissions that allow the connection to be attempted, network rules that allow the packets to flow, and routing that determines where packets can travel. Beginners sometimes focus on one control, such as a firewall-like rule, and assume the job is done, but cloud networking security is about the combination. A secure design aims to make required paths possible while making unnecessary paths impossible, and that reduces the opportunities for attackers to move or to reach sensitive systems. This is why segmentation is such a recurring theme in security. Segmentation is the deliberate shaping of paths so that compromise in one place does not automatically spread everywhere. In cloud networks, segmentation is often achieved through carefully defined network boundaries and policy rules rather than through physical separation. The key is to treat every allowed path as a security decision with a potential blast radius. Security groups are often best understood as resource-level allow rules that define which connections are permitted to reach a specific workload. The idea is that a workload should accept only the traffic it actually needs, and everything else should be blocked by default. A security group commonly focuses on inbound and outbound rules, such as allowing an application server to accept web traffic while denying other inbound access. For beginners, what matters is the principle. You specify allowed traffic based on protocol and port concepts, and you scope allowed sources and destinations so that only the right things can connect. When security groups are designed well, they form a tight boundary around each workload or set of workloads, limiting who can reach them and limiting what they can reach. That boundary is powerful because it reduces exposure and reduces lateral movement options if something is compromised. The most common mistake is treating security groups as convenience rules, where broad access is allowed because it works, rather than because it is necessary. Broad access may reduce short-term friction, but it increases the number of possible attack paths. In cloud security, path control is a form of risk control, so the default should be narrow and intentional. Network access control lists, often called NACLs, are another layer of network control that commonly operates at a broader boundary level. If you think of security groups as rules applied close to the workload, an ACLs often represent rules applied at a network segment boundary, shaping what traffic can enter or leave a defined segment. This provides an additional layer of enforcement that can support segmentation. For beginners, the most important concept is that multiple layers can work together, and you should not assume that one layer alone will always catch mistakes. A segment-level control can prevent certain categories of traffic from ever reaching workloads, which can reduce risk even if a workload-level rule is too broad. At the same time, a segment-level control that is too permissive can create a wide-open internal environment, where the only barriers are at individual workloads. This is not automatically wrong, but it can be risky if workload-level rules are not consistently tight. The best designs use layered controls to reduce the chance that one misconfiguration creates a major exposure. In practice, you want segment boundaries that make sense for the organization's risk, such as separating sensitive data layers from general application layers and separating management interfaces from general user access. Layering is not about complexity for its own sake. It is about reducing single points of failure in access policy. Routing is often overlooked by beginners because it feels like plumbing rather than security, but routing is security relevant because it defines what networks can reach each other. If routing provides a path from an internal segment to an external gateway, then traffic can potentially move outward, and if routing provides a path between segments, then traffic can potentially move laterally. Even if access rules are strict, routing mistakes can create unexpected exposure by connecting segments that were meant to be isolated. Another issue is that routing can be intentionally designed for business needs, such as connecting on-premises networks to cloud networks, and those connections can expand the threat surface if they are not tightly controlled. For beginners, the key idea is that routing establishes possibility, while security rules establish permission, and you need both to align. A secure design aims to ensure that only necessary routes exist, and that those routes are paired with appropriate access controls and monitoring. If you create routes broadly for convenience, you increase the number of potential paths an attacker can explore. In cloud networks, where creating routes is easy, that convenience can quietly turn into large risk if it is not managed deliberately. Exposure mistakes are often the result of misunderstandings about what is public and what is private in a cloud network. Beginners sometimes assume that if a resource sits inside a virtual network, it must be private, but privacy depends on exposure settings, routing, and access rules. A resource can be placed in a virtual network, yet still be reachable from the internet if it is connected through a gateway and allowed by access rules. Another common mistake is exposing administrative interfaces, such as management ports or remote access services, to broad source ranges. Even without focusing on specific ports, the idea is that administrative access should be tightly limited because it is a high-value target. Exposure mistakes also include overly permissive outbound access, where workloads can reach any external destination, which can make command and control and data exfiltration easier if a system is compromised. For beginners, the key lesson is that exposure is not only inbound. Outbound exposure matters because it affects what a compromised system can do next. A secure network design considers both directions and treats outbound rules as part of blast radius control. Another common trap is trusting internal traffic too much, which often shows up as allowing broad communication within an internal network segment. This is sometimes done to reduce complexity, but it can create an environment where one compromised system can easily probe and reach many others. In cloud environments, this can be especially risky because workloads are often created quickly and may not be hardened consistently. If everything can talk to everything internally, lateral movement becomes easier, and compromises become broader. For beginners, it helps to think of internal trust as a risk decision rather than a default. Internal networks should be segmented based on sensitivity and function, so that a compromise in a less sensitive tier does not automatically grant access to a more sensitive tier. This is why many designs separate user-facing components from data storage and separate management components from application components. It is not because separation is elegant. It is because separation limits damage. When internal communication is limited to what is necessary, detection also improves, because unexpected traffic stands out more clearly against a cleaner baseline. Cloud networking security also depends on consistency and change control, because cloud networks evolve quickly as teams add services and modify access. A network that was well segmented at launch can become porous over time as exceptions accumulate. Someone might open access temporarily for troubleshooting, then forget to close it. Someone might broaden a rule to support a new feature, then never narrow it again. Routing can also drift as new connections are added, creating new paths that were not considered in the original design. For beginners, the key idea is that network security is not a one-time architecture diagram. It is an operational discipline. That discipline includes reviewing rules for overbroad access, validating that segmentation remains intact, and monitoring for exposure changes. Monitoring matters because even a short-lived exposure window can be enough for automated scanning to find and probe a resource. When you treat network rules and routes as living controls, you reduce the chance that the environment quietly becomes more exposed over time. Another important concept is that cloud networking is closely tied to identity and workload design, because network boundaries are only one part of how access is controlled. Even if a network path exists, identity controls may prevent access. And even if identity controls exist, network exposure may still invite probing and exploitation. Effective cloud security aligns identity controls, network segmentation, and service-level access policies so that multiple barriers must fail before an attacker reaches sensitive assets. This layered approach also supports investigation because it produces clearer signals when something unusual happens. If a sensitive data store is normally reachable only from a specific application tier, then access attempts from elsewhere stand out. If outbound connections from a sensitive environment are normally restricted, then unexpected outbound attempts become high-signal events. For beginners, the takeaway is that cloud networking security is not separate from cloud identity security. They work together to define what is possible, what is permitted, and what is observable, and that coordination is what makes the environment resilient. When you bring these ideas together, securing cloud networking means deliberately controlling paths using layered rules like security groups and NACLs, designing routing so that only necessary connectivity exists, and avoiding exposure mistakes that accidentally make internal resources public or make sensitive management interfaces reachable too broadly. The most common risks come from overly permissive access rules, overly open internal communication, misunderstood defaults, and routing decisions that create unintended paths. For beginners, the most important lesson is to treat every allowed connection as a security decision, because every connection is a potential attacker path if something is compromised. Strong cloud networking security reduces blast radius by limiting inbound exposure, limiting outbound freedom, and segmenting internal tiers so lateral movement is harder. It also relies on operational discipline, because networks drift as environments change, and drift is a predictable source of new exposure. If you can explain what security groups and NACLs represent at a high level, why routing establishes possibility, and why exposure mistakes are so common, you will have a solid foundation for understanding how cloud networking decisions shape real security outcomes.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.